In this video, we are going to be focusing on problems under set operations that has to do with proving of distributive law. Let's say you are given this kind of problem that asks you to consider a universal set which is given from 1 to 9 and another set from 1, 2, 5, and 6. Next set is set B, which is 2, 5, and 7, and we have set C, 1, 3, 5, 7, and 9. And you are asked to prove using distributive law A intersection B union C is equal to A intersection B union A intersection C. How can we solve this problem? First of all, let's divide this A intersection B union C to be our left hand side. And the right hand side should be A intersection B union A intersection of C. And this is simply going to be the right hand side. Let's start from our right hand side. Left hand side. In this case, we are given A intersection B union C. And if you notice, in the right hand side, the possible thing to start with is B union C, because we need to know the value of B union C before we can find the value of A intersection B union C. In this case, B is what? Our element of B is 2, 5, and 7. An element of C is 1, 3, and 5, 7, and 9. The union of B and C is simply going to be B union C. This is simply going to be 1, 2, 3, 5, 7, and 9. Now that we know the union of B union C, we need to find the value of what? Or the element of A intersection B union C. In this case, notice that our A, the element of A is what? Element of A is 1, 2, 5, and 6. This and this, that's what we are looking for. Therefore, A intersection of B union C is simply going to be, okay, we are asked to find the intersection. Let's assume this is A and this is B. This is going to be B union C and this is going to be A. And we are asked to find the intersection. In this case, since our A, we have 1, 2, 5, and 6. B union C, we have 1, 2, 3, 5, 7, and 9. The intersection, which is in between, we are going to be left with, here we have 1, here we have 1. This is simply going to be 1. Here we have 2, here we have 2. We're going to have 2 here. Here we have 5. We're going to be left with 5, but we doesn't have 6 in common. In this case, we are going to have 6 in this side. Apart from 1, 2, and 5, what other element do we have in the case of B union C? We are going to have 3, 7, and 9. So we can conclude that A intersection of B union C is simply going to be 1, 2, and 5. Let's write it somewhere. Therefore, in the left hand side, let's say left hand side, A union B, A intersection. That's so. A intersection B union C is simply going to be 1, 2, and 5. This is for the right hand side. What about for the left hand side? Let's try it also. For the left hand side here, we are asked to prove A intersection of B union A intersection of C. And we know that our A here, that is in our A or element of A, is 1, 2, 5, and 6. What about B? Element of B is going to be 2, 5, and 7, 2, 5, and 7. Let's take an example. This is A and this is B. This is B. The intersection of A and B is simply going to be 2 and 5. In the case of A, apart from 2 and 5, we are going to be left with 1 and 6. In the case of B, apart from the 2 and 5, we are going to have 7. Therefore, A intersection of B is simply going to be 2, 5. What about A intersection of C? A intersection of C. In this case, these are the element of A. Let's find the element of C. Our given element of C is 1, 3, 5, 7, and 9. Therefore, A intersection of C is going to be this way. Let's assume this is A. Let's assume this is A and this is A. I say A and this is A. And we said we are looking for the intersection, which is A intersection of C. The intersection is simply going to be, A intersection of C is simply going to be 1 and 5. Because those are the things we found in common. A intersection of C is going to be 1 and 5. In the case of C, apart from the 1 and 5, what do we have next? We have 3, we have 7 and 9. But this is not what we are asked to find. In the case of A, apart from 1 and 5, we also have 2 and 6. Therefore, at this point, we can state A intersection of C. A intersection of C is simply going to be 1 and 5. Remember, the problem says we should find A intersection of B union A intersection of C. Therefore, A intersection of B is 2 and 5. Union A intersection of C is, that's what we are, that is the next thing we need to find. So we can conclude and say A intersection of B union A intersection of C. And A intersection of B is simply nothing but 2 and 5. Union what? A intersection of C. Therefore, the union of A intersection of B union A intersection of C. Let's use this diagram. It's simply going to be, let's assume this is our A intersection of B, and we have to find the union with A intersection of C. I mean, we don't even need the diagram. We can easily find it. So the answer is simply going to be, here we have, the value of A intersection of C, we say is 1 and 5. So, therefore, the union of this is simply going to be 1, 2, and 5. Let me take this for the last time. Let me repeat it. We said at this point, the last thing we asked to find is what? Is this. That is from the right hand side, which is A intersection of B. A intersection of B is what? Is 2 and 5. What about A intersection of C? A intersection, what are intersection? A intersection of C is what? Is 1 and 5. So the whole problem says we should find A intersection of B union A intersection of C. In this case, we are going to find the union of this. This is simply going to be 1, 2, and 5. If you notice previously, I defined this problem to say our left hand side is what? 1, 2, and 5. Here we are going to say our right hand side is simply what? 1, 2, and 5. And this is it for this problem. Since both left-hand side and right-hand side are equal to 1, 2, and 5, the distributive law holds true for the given set. So this is it for this problem. Feel free to comment down below in case you have any other question. And you can feel free to check other videos on set operation. Thank you. In this